We would like to calculate the distance to far stars. In this particular example, we would like to calculate the distance to Betelgeuse. Betelgeuse is a famous star in the constellation of Orion. It is known as Alpha Orionis. It is the star in the upper left corner of Orionis. And notice that it's this bright orange colored star. This image is courtesy of Hubble under the NASA Hubble telescope, and it is under public domain. We're given Betelgeuse's apparent magnitude small m sub v, which is equal to the same thing as capital V, and that is equal to positive 0.50. The absolute magnitude of Betelgeuse is capital M sub v, and that is equal to minus 5.85. Since Hubble mainly views in the V band or the visible band, we had put subscripts down for absolute magnitude and for apparent magnitude, or we just put in capital V instead of small m sub v for apparent magnitude. We would like to find the distance in units of parsecs to Betelgeuse. We're given a conversion of 1 parsec to 3.26 light years should we need it. We're using the equation small m sub v minus big M sub v is equal to 5 log d minus 5. All we need to do is substitute into the values. So we have small m sub v is equal to positive 0.50, and I went ahead and put it in there, minus parentheses, and we're looking for big M sub v. Big M sub v is minus 5.85. I went ahead and put it in, close parentheses, and that is equal to 5 log d minus 5. First thing we want to do is handle the left-hand side of the equation. And on the left-hand side of the equation, we have 0.50 minus, and then we have a minus 5.85. Well, a minus is the same thing as a plus plus. So we're just going to change them to pluses. So we want to take on the left-hand side of the equation, we want to take 0.50 plus 5.85. So let's plug it into our Google calculator, 0.5 plus 5.85, and that equals 6.35. So we want to put on here 6.35 on the left-hand side of the equation. Now remember, we want to isolate d on the right-hand side of the equation. So the next thing we want to do is get rid of this minus 5. So we want to add on 5 to both sides of the equation. Well, the right side of the equation is just 5 log d minus 5 plus 5. So you have your minus 5 adding on a plus 5, and you're going to be left with just 5 log d. Because minus 5 cancels with plus 5. On the right-hand side of the equation, you have 6.35 plus 5, so we want to add on 5, and we're left with 11.35. The next thing we want to do to isolate d on the right-hand side of the equation is divide both sides by 5. So that's what we're going to do next, divide by 5. On the right-hand side of the equation, we got a 5 log d divided by 5, and the 5's just cancel out, so we're left with log d on the right-hand side. On the left-hand side, we have 11.35 divided by 5. Let's go put that in our calculator. So we already have 11.35, we divide it by 5, and we're left with a 2.27. So now we have a 2.27, and that is equal to a log d. Now you have to go back and remember your log scales. Log scales are log base 10, and that means 10, and this is your exponent, 10 to the 2.27, is equal to d. So we put our 10 in here. Our exponent is 2.27, 2.27, and that's going to equal d. So all we need to do is take 10 to the 2.27. So it's log base 10, 10, and this is the exponent, 2.27, and that is equal to d. 10 to the 2.27. So let's clear that out. Let's put in a 10, x to the y, 2.27. We hit equal, and we have 186 as our answer. So d is 186 parsecs, and that is the distance to Betelgeuse.